I would just like to give a preview of the optical aspect of the physics Waec practical. So now these are the materials that we might be asked to that we asked to provide. These materials: the rectangular glass block prism. We are asked to provide the plane mirror. We are asked to also provide the optical pin. Then we might need, since you are coming for this type of practical, you will need your meter rule and your protractor, then your pencil, maybe a paper tape to hold your paper to the cellulose board. Okay, so let's quickly move into the main thing. Now I'll show you a prototype question. I think this question was brought, that was in 2020. You can see the diagram. That is diagram that we are going to use to explain this optical area of the question. So let's look at the question. You are provided with a glass block, a plane mirror. Now this is the glass block. I want you to be reading the question somewhere. You are provided with a glass block. This is our glass block, a plane mirror, optical pin. The optical pins are here. You can see these are new ones, this set. So I'll be needing just 4 of these optical pin. You also provided place the glass block on a drawing sheet. So that's the first thing. So if you're using an A4 paper, you might need to place it here if you are doing this kind of practical, so that you have more diagrams to draw. You have enough space to draw your diagrams. But if you can also make use of 2 plain A4 papers. So we are told that place the glass block on the drawing sheet and trace its outline. So let me put this at the center because I will just draw only one. Let me make use of a very sharp pencil to have a neat traces. Trace its outline. Trace its outline ABC as shown in the diagram above. So let me also bring the diagram that we are shown. This is the diagram. So we are going to label this A, B, C, and D. A, B, C, and D. Now the next instruction. So everything in physics practical is just following instruction given. Remove the glass block. I've done that. Measure and record the width W of the block. You can see that the width W is the side AD. So I'm going to take this and measure, and this is giving me 6.7. So W is 6.7 centimeters. I've measured that. Then draw a normal ON to DC at a point about 1/4 of the length of DC. The length of DC, you calculate the length of DC. Look at the length of DC. The length of DC is 10 centimeters. So in this case, then you can 10 divided by 4, 1/4, that's 4, divided by 4, that's 2.5. So just mark 2.5 up and mark 2.5 down. So well, I don't need to mark the up, just mark it here. Then use your protractor. So you use your protractor make sure it balances with the line, then mark 0.90 here. So we can draw our normal. So these are normal NO. If you do that, then the question says draw a normal NO to DC. This is the DC. At a point about 1/4 the length of DC, draw a line making an angle I equals to 10 degrees with the normal. So you're going to take this. Now you can turn it. Make sure the line are properly aligned. So this 90, this is 90. So the angle of incidence they told us is 10 degrees. So you mark it at this 100 point 100 here. That's 10 degrees from the normal. So you can draw that line. Draw it a long line. Make sure you have neat traces. That's one of the precautions in optical experiments. Now the next thing you need to do is, from the instruction, replace the glass block. We are replacing the glass block now. Replace the glass block on its outline and mount the plane mirror vertically behind the glass block. So we are mounting the plane mirror behind the glass block, then such that it makes good contact with the face AB. So this is having good contact with the face AB. Then stick 2 pins, pin 1. Let's put P1 here. Make sure the spacing of your optical pins are at least 4 to 5 centimeters. So make sure the pins are erased. That's one of the precautions. I ensured the pins were erased. So erase pins. Then, such that it makes good contact with the face AB. Now stick to the 2 pins P1 and P2 on the line MO. So we have done this MO. Remember to put your ray line MO. Then looking through the face CD. So we are going to look through this face CD, and let me put the next question here. So we are looking through the face CD. Stick 2 other pins P3 and P4 such that they appear in a straight line with the images of pin 1 and P2 seen through the block. So what we're going to do now is we are going to be looking through this. You can reduce the length. We are looking through okay. Now let me look through the we want to put our pin at a point where you're going to have a, let me first make my own trial. You must be careful not to look at the image of the pin from the mirror directly. You are looking through the face CD of the glass block. I'm making sure that this pin 3 P3 is in straight line with the other 2 pins inside. And if you check very well, you can see, looking through, you see the point where the 2 pins, at this point you can see the 2 pins they're having parallels. Then you're setting it to make sure that this covers the other 2 pins, and then we move on to hold it. Let's put the last pin, the pin P4, and we are making sure that this pin P4 must be able to, excuse me, so can you see now that this pin P4 is actually covering pin P3 and the images of the P1 and P2. So this is actually the method of carrying out this experiment. Now we are going to look at the next instruction. It says that we should remove the pin, join P3 and P4 with a straight line and extend it to touch the face CD. So we can remove the pins now. We are removing the pins. So I'm going to join P3. This is P1 according to the diagram. We have P2 here, P1 here, P3 here, and P4 here. Make sure that the O's of the pins are showing in your diagram. So this is the emergent ray. Then we are told to draw, the instruction says draw a perpendicular line from the midpoint of COO. This is O and this is O prime. O prime to meet AB at Q. So then let us first draw. You need to draw the normal to this. So find the angle 90 of this point. The angle 90 of this point. So this is our 10 degrees. No, there's an error here. There's an error in the normal here. So we have a P3 here. Now we are told that you should draw a perpendicular line from the midpoint of OO prime. So the midpoint, we have to find OO prime. OO prime, we measured it. We are measuring OO prime, and the measurement gives us 1.3. So OO prime, that's 1.3. The middle of 1.3 is 0.75. No, it's 0.65. So let's take this 0.65. Then use your protractor to set the angle 90 from it. Let's see what I'm doing. Coming, this is 0.65, 0.65. Okay. So okay, so now from here you join this line to this line, then you join this line to this line. So this angle here is angle theta. Let's call this one I. This is our E. So let us measure E. Our angle E here is 7. Our E here is 7. So I is 10 centimeter, 10 degrees. E is 7 degrees. Theta will be, you're not capturing what I'm writing. So theta, how do we measure theta now? I can measure theta this way. Just put it at the middle point and read from the first one to the second line. So you are reading from here to here. So this is 5, 6, 7, 8, 9, 10, 11. So theta is 11 degrees. Theta is 11 degrees. So I measure this, and that's I measure from here to here, from this line to this line to get your theta. And draw lines OQ. I think we have done this. Measure and record cos theta. So in our, to get the table of values, you might need to draw something like of this sort. Let's say this serial number. Let's say maybe serial number here. Second iteration, fourth iteration, fifth iteration. So the first thing that we are recording, we recorded the I in degrees, and some of we have a 10. The first one is 10.0, 10.0. The second one, I think we're told to do 20.0, 30.0, 40.0, 50.0. Capture what I'm doing. Capture this list. Now we are told to also find the E in degrees too. So the first E we found is 7.0 degrees. Then if you do other ones, we are told to also look for our theta also in degrees. The theta also in degrees, so you can get the value of theta. We have value of theta here, as 11.0 degrees. Then we are told to evaluate, measure and record cos theta, E and D. So we have to find cos theta too. So our table of values should have this. Then our D, the D is actually OO prime. So our D in centimeters, you have to put it there. D in centimeters is 1.30. So then evaluate M equals to sine E. So we are going to look for M. Our M, which is sine E, the sine of E. So whatever you have got as your E, the value of E, whatever value you got for E, you need to find the sine of it, and you must make sure that this is in 3 decimal places. Let me use a longer pencil. 3 decimal places. Now we are also told to find N. So the table of values, all these must be on a straight line. N equals to cos theta over 2. Cos theta over 2. You must make sure that all these values are all in a table. Do not break this table. If you break this table, you are going to lose mark for composite table. So it's better you draw everything on a single table, and that is what is required of you for let's see the other question. Let's see now. We are told to tabulate your results. So plot a graph of M. So when you're drawing your graph, make sure you plot M on the vertical. So it's a graph of M on the vertical. M will be on the vertical against plot a graph of with M on the vertical and N on the horizontal axis. So you are plotting M on the vertical. Make sure you also identify your axis. That's one mark for you. Then have a good scale. Then with a good graph plotting, you are good to go. Then sketch a diagram to show the path of the ray through the glass block when the angle of incidence I. So you have to sketch a diagram to show the path of the ray. So this is like saying, okay, through the glass block when the angle of incidence is 90 degrees. So when the angle of incidence is 90 degrees, and that is like this, angle of incidence that's parallel to this, you have to sketch the kind of ray that will be formed. Well, this, from here, at least you have an idea of how to set up your experiment for optics. So we see again in the next video for electricity. Thank you. Thank you.